This is section 9.1 in trigonometry. What we're going to be doing in this section is solving right triangles. The good thing is that this is something that you definitely learned in geometry. It's a review. But what we want to start off with is what are main things that we deal with in trig are the sine, cosine, and tangent functions. Okay, now one of the things that we have to remember is that if this is sine of theta, this is cosine of theta, this is tangent of theta. This symbol is theta. What that represents is an angle measure. So that's the angle measure in our triangle in this case. And also what we have to understand is this is not sine times theta. This is not cosine times theta. This is not tangent times theta. This is the sine of theta. It's the sine of an angle. When we deal with sine, cosine, and tangent, what it does is it represents the ratio of the sides of triangles. So this is where the word or the saying SOHCAHTOA comes in to help us remember that the sine of theta will always be equal to the opposite over the hypotenuse. The cosine of theta will be equal to the adjacent over the hypotenuse, and the tangent of theta will be equal to the opposite over the adjacent. Now, looking at this, what's really important to understand is that the opposite side is not always this side. The opposite side is always based on what the angle is. So if we're dealing with theta here, opposite means across from where our theta is. Our adjacent will be next to. The hypotenuse is always the same side. It's always what's opposite of the hypotenuse. So across from the hypotenuse is always what's across from the right angle. So the right angle, there it is, across from that is always the hypotenuse. How do we know that? Well, because the hypotenuse is the longest side of the triangle, and the longest side will always be across from the longest angle, and in a right triangle, where the 90-degree angle is always your biggest angle. So these are the ratios that we're going to be dealing with all of these, and we just need to make sure that we appropriately name our sides. So let's go on and let's look at this example, and we're going to talk about how we're going to use this. We're going to be solving the right triangle. What does solving the right triangle mean? Solving the right triangle means that we want all sides and we want all angles. Okay, so this first one's actually pretty easy because we have a 90-degree angle, we have a 70-degree angle. We should easily be able to figure out what angle A is by taking 180 degrees, because we know there's 180 total degrees in a triangle, minusing 90, there's our 90, minusing 70. Okay, so when we minus 90 minus 70, we're left with 20 degrees. So this is 20-degree angle right here. So we have angle A equals 20, whoops, not square root, back into the Algebra 2 days. So angle A is going to be equal to 20 degrees. So that's the first part. Now we need to figure out what our missing sides are. So here's where we're going to use our ratios. Now, depending on which angle you want to use, it doesn't really matter. So first decide which angle you want to use. So if I'm going to use 70, then what I'm going to do is I need to figure out what A or C is. Remember, we can only do one at a time. So if we do one at a time, let's say we want to figure out what angle C, or side C is first. That is our hypotenuse. This right here is our opposite. So therefore, we can do the sine of 70 degrees. That is equal to the opposite, which is 15, over the hypotenuse, which is our C. And then we're going to solve for our C here. So what C will end up being equal to, and I am skipping a step here, but basically what we're going to do is we're going to multiply C to both sides, and we're going to divide sine of 70 to both sides, and we're going to be left with 15 divided by the sine of 70. So again, all I did was I multiplied both sides by C, canceled out, and then I divided both sides by sine of 70. So the sine of 70 cancels out, so we're left with C equals 15 over the sine of 70. Okay? So basically, we are going to put that into a calculator. Now, one thing to make sure, in your graphing calculator, you want to hit the mode button. And when you hit the mode button, you want to make sure that you're in degree mode. The third line down, there's one thing that says radian, and the next thing, and what's next to it is degree. So for now, we want to make sure it's in degree mode. So we actually put into the calculator 15 divided by the sine of 70. and you should get 15.96. So C is equal to 15.96. Okay, so we have our C, we have our A. Now we just need to figure out what our, we have our angle A. Now we need to figure out what our A is. So there's a couple of ways that we can do this. Now that we have two sides of our triangle, we can use the Pythagorean theorem if we want to. So in other words, we could do 15.96 squared equals 15 squared plus A squared, and solve it that way. There's nothing wrong with doing that. So we have 15.96 squared is equal to 254.72, and then equals 225 plus A squared. So then we have A squared equals 29.72. Then we want to take the square root of both sides there. And we get A equals 5.45. So now we have all of the missing pieces that we needed. We have angle A, we have side C, and we have side A. That's how you solve a right triangle. You could have also solved A using trig. You could have, we have the angle right here. We could have done cosine of 70 equals A over 15.96. We could have done tangent of 70 equals 15 over A. We can do sine of 20 equals A. There's a lot of ways that you can do it. Once you have two of your sides, you can use almost any trig function or the Pythagorean theorem to find the third side. Okay, so in our next example, what's going to happen is here we are just looking for missing angles. So this is a little bit different method. What you notice is we don't have any of our angles except for the 90 degrees. So it's impossible for us to guess or know what our beta and our theta will be. But what we can do is we can still use trig functions. So watch what I do here. I'm going to set this up. I see that I have, if I look at my theta, I have my opposite and my hypotenuse. So if I do the sine of theta equals 3 over 5. And then I also can do beta as cosine of beta equals 3 over 5. Again, you look at theta, opposite is 3, hypotenuse is 5. If you look at beta, adjacent is 3, and hypotenuse is 5. So what happens is, how do we solve this equation? Well, remember, this is not multiplication. We're not dividing by sign to get rid of it. But what we can do is we can use something called the inverse trig function. And this is on your calculator. It's the second function and then the sign button. What happens is remember, anytime we do an inverse, all we do is reverse our x and our y. Well, theta is like our input. 3/5 is like our output. So we're going to do inverse sine of 3/5 in our calculator. And that will actually be equal to theta. And if you put that in, you get 36.87 degrees. Again, we're in degree mode, so it should give us an answer in degrees. Same thing with the cosine. So then we do cosine inverse cosine of 3/5 will actually be equal to beta, and that is equal to 53.13. And then you would notice that if we were to add these up, we get 90, plus our other 90 gives us 180 degrees in our triangle. So that's how you find missing angles when you know what two of your sides are. So you can set up any trig function the way you want or the way you need to, and then do an inverse if you're given two sides. Okay, so hopefully that helps. Okay, and then the last thing that, or next part on this is I want you to do this one on your own. Okay, I want you to solve the right triangle. In other words, I want you to figure out what C is, and I want you to figure out what angle A is and what angle B is. Okay, so I want you to find all of those. So to find C should be pretty easy, and then you can figure out what your angle A and B is by doing what we just did. So you're going to do this on your own, and make sure that you try this and answer the question. So hopefully going through this, the first thing you do is do the Pythagorean theorem to figure out what your C is. So you get 9.434. For your angles, if we look at B, the sides that we have based on B is the opposite and the adjacent side. So that has to be tangent. So tangent of B is 5 over 8. inverse tangent of 5 over 8 is 32.005. Same thing is true with A, opposite and adjacent. We have opposite, adjacent, inverse tangent is 57.995. The last thing I want to cover is special right triangles. Now this is something that you definitely have covered at some point in your geometry class, but what we want to make sure is that we understand how the ratios of this is going to work. So understand that if you have a 45 degree, 90 triangle, these two legs are going to be equal to each other. So what I'm going to do is I'm going to mark these as X, okay? And the reason why I'm going to mark them as X is because they can be anything. If I say this is 5, then that means this is 5, okay? And then what we can do is set up the ratios of each one of these sides as such. So if this is X, or if this is 5, this is 5. And that means our hypotenuse is going to be X times the square root of 2. So in other words, if this side is 1 and this side is 1, then this side will be square root of 2. If this side is 2 and this side is 2, then it'll be 2 times the square root of 2. It will always be at the exact same ratio of each of these sides. So whatever this side is, this side will be, and then you'll be multiplying that times the square root of 2 for that one. For a 30, 60, 90 triangle, it's a little bit different, but similar. The opposite side of a 30 of a normal triangle is 1, so we're going to call that X. So normally it's 1, but it can be anything. We just have to make sure that it is proportional to every other side. Our opposite of our 60 degree angle is always going to be X times the square root of 3. So whatever our smallest side is, it's going to be multiplied times the square root of 3. And then our hypotenuse will always be 2 times X. So the hypotenuse will always be double of our shortest leg, the one that's opposite of the 30. So X, 2X, and X times the square root of 3. Okay, normally it would be 1, square root of 3, 2, but obviously the sides of a triangle can be anything. We just have to change every side as such. Okay, so that's it. That's all I got for you. Make sure that you have finished this video. Make sure it plays until the end. And if there is an Edmodo quiz, then take that. But I think the Edmodo quizzes are pretty much done. So I'll see you in class.